Hello, students. Okay, welcome to our program Smart Way to Success 2.0. Okay, so today, we are going to proceed to our slot 4. So basically, we are going to concentrate on the chapter 10, Special Probability Distributions. Okay, so for today's presentation, so I'm going to concentrate on 4 basic parts. First is the analysis of previous Pspm2. Secondly, we're going to go to the summary notes. Third, we are going to go to the cron Pspm questions, and finally, we're going to get the feedback, student feedbacks, and so on. Okay, so for the analysis of previous Pspm, so I'm going to go through the year 2015 and 2020. So basically, we know that this topic is a quite famous topic in the final exam. Okay, so we will see that according to the analyze, so we can see that most which subtopic like binomial distributions, Poisson distribution, normal distribution, and distributions approximations, they come out in the final exam. So they can say that for each year, every 4 parts of this, they will ask some questions on this. So according to the justifications tables for this year, so almost 25% of the question is from this chapter 10. Okay, so before we going further into the questions, okay, let us go to the summary notes first. So we go for the summary notes for this. Okay, so we will see that in these chapters, so basically we have the 4 main subtopics. One is the binomial distributions, second one is the Poisson distributions, and the third one is the normal distributions, and finally is the distributions approximations. Okay, so we can see from the analyze that basically all of these parts, okay, they were asked during the exam. Just now I mentioned that, okay, according to the justification tables that we have, almost 25% of your Pspm questions were based on this chapter 10. Okay, so let us recall, okay, what is the important things that in the chapter 10 special probability distributions. Okay, if you still remember, so we have 2 kinds of special distributions. One is categorized as discrete, and the other one is the continuous. Okay, so for this discrete, so we have learned the binomial distributions and the Poisson distributions. And for continuous, we only learn the normal distributions, and finally, so we are going to use the approximations. Normally, we are going to use the normal distributions to approximate the binomial distribution. So this is the final part in the exam. Okay, what is important in binomial distributions? Okay, as we know, binomial distributions, we have 2 main important parameters. There is n, is the numbers of independent trial, and the p is the probability of a success on each trial. Screen tak gerak. Okay. Ada dekat skrin dah gerak. Okay, tak apa. Saya share balik. Okay. Kejap Oh, I try to share entire screen. Okay. Okay, sorry for the technical problem. Just now the screen dia tak bergerak. Okay, so for the binomial distributions, okay, so we have the two important parameters. One is the n is the number of independent trial, and the p is the probability of a successful on each trial. Okay, this is why during the examination, so when you look at the question, you have to try to find whether we have these two parameters or not. Okay, so if we have, though, this distribution is suitable for us to solve by using the binomial distributions. Okay, so basically we have two ways to find the probability. Is we use the formulas of probability distribution function. This is the formula of binomial distribution function. Another is that we can get the probability from the binomial probability table, what is you call as the statistical tables. Okay, however, there is a limitation. Okay, if you read the probability from the tables, we only restricted to the n greater or equal than 3 and less or equal than 50 only, and for the probability of 0.01 until 0.5. Other than this, so you have to use the formula of probability distribution function to calculate. Okay, if the questions given is not in the range, so you must use the formula to calculate. Okay, and students have to take notes that okay, the probability that given in the statistical table is the probability of obtaining R or more success in an independent event. This is why normally, so if you want to use the statistical table to find the probability, so we will use this property, three of this property. X is equal to R, using the x greater or equal than m and minus the x greater or equal than r plus 1 and so on. Okay, after this, I will teach you a method. Okay, how to do this or how to use this formula easily without memorizing the formulas. Okay, and then for the binomial also, you need to know how to find their means with the NP, variant with the NPQ, and the standard deviation is the square root of NPQ. This is basically what is the note or important things in the binomial distribution. And we proceed to another discrete distributions. That is what we call the Poisson distributions. Okay, Poisson distribution is the distributions that be related to the size, space, or volume. And for the Poisson, the parameter is the mean. Mean, this is the lambda. Is where normally we denote it as lambda. Lambda is the mean number of occurrence in the interval. Okay, so same thing for to calculate the probability in the Poisson distribution. Okay, we may use the formula e power of negative lambda, lambda power x divided by x factorial, or we may also get the probability from the statistical table, which is on the Poisson probability table. Okay, again, there is the limitations of lambda also. So we only can read the value for the lambda 0.1 until 30 only. Okay, so again, take notes, the table gives the probability of obtaining R or more. R or more. So take note, the value that stated in the table is the probability of obtaining R or more. Okay, maksudnya dia adalah cumulative. Dia add on Okay, so and again, we are going to use this property to find all the probability based on this. After this, I will teach you a matrix. Okay, so same thing for Poisson, we also have the mean. Okay, of course, we know that the mean is the lambda, and the variance is also same value with lambda. And if you want to find the, it's the standard deviation, you just square root of lambda. So this one you have to take notes. Okay. Okay, just now I mentioned that, okay, how I'm going to do this or memorize this easily. Okay, so I will teach my students a petua. This is the petua that I create. Okay, called petua gigi palsu. Okay, gigi palsu normally dia adalah, is one piece by one piece. Yeah, it's the same. It's the same concept with the discrete. Okay, for example, let's say I'm going to find the probability f equal to r. So how I'm going to do that? The probability says that I'm going to use the probability greater or equal than r, subtract with the probability s greater or equal than r plus 1. So when I subtract, okay, I will get the probability of f equal to r only. Okay, see, very easy. You no need to memorize. You just draw your gigi, okay, and you label your gigi, ascending order. Okay, so for the second formula, it says that f less or equal than r. Okay, I may use 1. For gigi, I subtract with the f greater or equal than r plus 1. So saya tolak, I subtract. That is why I will have this. Okay, so very easy. Okay, the third one, I say that less than r, that's been not included. Dia tak termasuk Okay, so I use whole gigi is 1, and I subtract with the r and so on. Okay, r greater or equal than 1, because we can read from the table is the r greater or equal. Okay, so that's why I subtract, so I will get this. Okay, this is how I teach my students. Okay, normally they just for the discrete distribution only. For the discrete distribution, they may use this to represent. Okay, how many pieces of gigi you want to draw up to you, but at least 3 lah. Okay, at least 3. Okay, boleh? Okay, at least 3 Okay, so the next distributions that we do, the final one is the continuous distribution, is the normal distribution. For normal distribution, so we have two main parameters. That is the mean. Okay, we denote it as the mu, and the variance as the sigma square. Okay, so for normal distribution, the formula for the probability is very tough. So normally we won't do the calculations, but we will read from the table. Okay, to read from the table, so we have to do the standardized process. Because in the statistical tables, we only have the standardized normal distributions value only. So we have to change. Okay, from the normal distribution to the standard normal distribution with the mean of 0 and the variance of 1. So this is why this is the normal process. Okay, you have to do before you read from the statistical table. Okay, so kita akan baca this one. Okay, standardized normal distribution from the table. Okay, again, so there is a limitation also. Okay, for the table only shows the, is the z for the 0 to from the 0.5 up to the 0.001 only. So there is the limitations from the table. So we have to, you can refer the page 21. Okay, so to read from the table, normally, okay, we have to have some basic concept of this. So we always use the concept of reflection. Okay, so for example, the table of z less than 0.1 is equivalent to the value, the probability z is greater than 0. So because your table only give you the value, of this side only. Okay, the value of greater than 0 this side, so this is equivalent. Okay, so the probability less than minus z this way, so they are equivalent. Okay, the region is the same, the probability is the same if z is greater than a. Okay, if you want to evaluate the probability z greater or equal than a, less or equal than a, okay, you may use the probability of greater or equal than A subtract with the Z greater or equal than B. Of course, for the continuous distribution, we know that there is no equal sign lah. So yang ini dia tak termasuk Okay, so for Z greater than -1, so this part, they are equivalent, okay, to the 1 minus the Z greater than A, I'll say. And if you want to find the probability in between -A and A, okay, so this one, you have to do 1 minus 2 probability of Z greater than A. So that means we just subtract these two parts. So we are going to get the region in between. Okay, basically this is what we have done in the chapter 10, and this one is related in the chapter, it's the chapter 9 also. You have to refer back. For normal distribution is the continuous distribution, so there is no equal signs for the probability. Okay, so after this we go to the final part as the part of distributions approximations. Okay, so for your syllabus, okay, we only do the approximations from the binomial to normal. Okay, so we will do this when your n is greater than 50. Okay, so we will do the approximation. So that means that I'm going to change from the gigi, this one, the discrete part, I'm going to change to the normal belt. So I'm going to change the binomial to normal. It means that I'm going to change my distributions from the discrete to continuous. Okay, this is why for this process, we have to add on a process that we call the continuity correction. So you see class, when I do the binomial, I change to the normal belt. Okay, I need to do some adjustment. This adjustment that we call the continuity of correction. Okay, continuity of correction. And sometimes the question will ask, okay, when we are going to use the normal distribution as the approximation. Okay, normal distribution is suitable for us to approximate the binomial distributions. Okay, when your MP is greater than 5. And the P, of course, should be in between 0.1 and 0.9. Okay, so this is the main thing. Okay. So just now I said that. Okay, so continuity correction. Okay, and I think all of you already know. Okay, from to change or to do the continuity corrections, we have to do some adjustments as this. Okay. Okay, macam mana kita nak buat? Okay, you see we are going to follow the sign except the equal sign. Okay, so just now I already give you the video, okay, on how we're going to do this process of continuity by using the petua gigi palsu. This is what I teach my student. Okay, how we're going to change this easily? Okay, to do the CC, okay, our correction of continuity, so easily kejap minus 0.5, kejap plus 0.5, very confusing. Okay, my student very confusing. So that's why I teach you a simple way. Okay, let me show you. Okay, basically to do this, we only have 4 simple steps. Okay, just now we say that we change the discrete to continuous. So kita nak tukar discrete to the normal belt. Okay, so and have to do the adjustment. When we know that when we negative and when we plus. Okay, so I teach you a simple way. Okay, so we only need 4 steps. Okay, we only need these 4 steps. Okay, so step 1, we draw the gigi pulse. So we draw first as much as you like. Okay, but at least 3. Okay, so then we must label your gigi A minus 1, A plus 1, A plus 2. That means if you label it as 3, so this one should be 2, and this one is 4 and 5, up to you, based on the questions given. Okay, after you draw your gigi and you shaded the selected gigi up to the question or based on the question. Let's say I'm going to, kalau I shaded ini, saya nak is the greater than A. So saya akan shaded A plus 1, A plus 2, let's say. Okay, step 3, I draw my normal belt. Okay, saya draw saya punya normal bell. Okay, step 4, I write the continuity. Okay, you see, when I write, I cut. Okay, so this is the gigi A. So gigi A, I have to adjust plus 0.5. I have to go this way. Okay, I have to go this way. That's why, and I do the corrections. Okay, I will have the A plus 0.5. If you read from here, okay, A plus 1, so you have to do the adjustment reverse to the left hand side. So you are going to do the A plus 1 minus 0.5. So you are going to get the same thing also. Okay, so this is how I teach my student. Okay, we read based on the cutting point here. After your shaded region, okay, step 1, we draw the gigi. Step 2, we shaded the selected gigi that you want based on the question. Okay, step 3, we draw the normal line. And step 4, so we state the corrections continuity formula. Okay, clear? Boleh? Okay, so for now, okay, we have a try. Okay, every one of you, you can take a piece of paper. Okay, we try together. So we try together. Okay, so from the binomial consistency formula, so we know that f equal to a, we have to change the correction, change to normal approximation by using the correction formula of a minus 0.5 less or f is greater than a minus 0.5 and f is less than a plus 0.5. Okay, how I'm going to teach, okay, how I'm doing, okay, so I show you. So let's say for the same questions here, I'm going to be interested in x equal to 10. So this is the regions that I want. I shaded. Okay, I shaded. After that, I draw my normal bell. Okay, I draw my normal bell. Okay, step 3. Okay, I cut. Okay, and I start to read. Okay, the gigi here, okay, the shaded region should be same region as the normal bell. Okay, yang ini, normal bell. This is why I change. I will get, okay, here is 9.5. Okay, here is 10.5. I have to do the corrections to the value of x is greater than 9.5 and less than 10.5. Okay, clear? Okay, so very easy. Okay, very simple and easy. Okay, I give you 1 minute to try the second one. Okay, if you already get the answers, then you can write on the live chat corner. Okay, I give 1 minute to try for the second. This one. Okay, x is greater than 10. Based on the gigi, okay, what is the corrections formulas that you get? Anyone? If you already get the question, so you can write, okay, in the live chat. Okay. Here, show me the corrections formula. Okay, already have Fahana, Badila. It says that is greater than 10.5. Ada lagi? Okay, Nodina pun. Okay, bagus. Very good. Okay, we try and see. Okay, greater than 10. Tak termasuk 10 kan? Okay, so tak termasuk. So we will have this. I shade it. I draw. Okay, I will have this. This is why I will have greater than 10.5. So ini anjak ke kanan. So it's the 10.5 greater. Okay. So this is why I have the f is greater than 10.5. So very good. Okay. So you see, you don't need to memorize. You just can draw. Okay. Easily. Okay. For the third question. So if you have less or equal than 10. This one you will have what? If less or equal than 10. Termasuk 10. Less than. So I may easily So correct it by what? By less than. Okay, Nuru Nodina. Okay, it says that is less than 10.5. Okay. Okay, betul ke? Okay, betul. Bagus. Very good. Okay, so you see, so this is the important step before you do the, is the approximations for finding the value from the table. Okay, very good, Okay, so if you have the less than 10, okay, so lama-lama you dah makin pandai dah. You may draw this in your mind. Okay, less than 10 dia tak termasuk 10. So dia adalah where is the region? Okay, for this less than 10, so we will have this, right? Okay, less than, dia tak termasuk. So discrete is very particular whether they include or not. Okay, so kalau less than 10, okay, so less than 10, so I draw my normal bell here. I do the cutting point. Okay, this is the 10. Okay, so we have to do this reverse. So maksudnya 10 minus 0.5. So you have the 9.5. So 10 is less than. Okay, the F is less than 9.5 and so on. Okay, if you have time, you go back and try by using the methods that I teach you. Okay, so you will find it very easily or very easy. So to do the corrections of continuity or continuity corrections by using the gigi palsu. This is why I call it as gigi palsu, is because I want my students to remember it. Okay, this betul. Okay, okay, so basically, okay, you can have a try. So kalau besar sama 10, okay, so besar sama 10. So all these regions that I want. So I cut. Okay, this is why I will get. Okay, Okay. Okay. Okay, you can go back and try for the third one. Okay. And if I have the last one, this one, 8 greater than 8 and less than 11, greater than 8 is this, and less than 11. Okay, so this is the regions. Okay, this is why this is the greater than 8. So this is the 8.5 kan? So ini dah 10.5 Okay, this is why you have the greater than 8.5 and less than 10.5. This is how we get. Okay, I hope that this method can help you, okay, to form the continuity corrections formula, okay, in the final exam after this. Okay, beside that, okay, there's some important words on max operator also play an important role in helping you to answer the questions. Okay, this is the words or the max operations that I can remember. I already read out. Okay, basically during the exam in the chapter 10 questions, you are going to go to read through all these less than, more than, at most, at least, exactly, between, and inclusive, not more than, and so on. Okay, make sure that you convert to the max operator correctly first. Okay, before you read from the statistical table. Okay, for discrete, especially binomial and Poisson, they are very particular. Okay, whether you include or not include. Okay, boleh? So this one be careful. Okay, so for normal, okay, so there is not such not big problem. Okay, because there is no equal sign, okay, in the continuous part. Okay, but so be careful. So this is why I already list out. Okay, make sure that you convert it correctly. Okay, convert it correctly. Okay, and I already give you, this one is in your handout. You go back, you can go through or read through. Okay, so now, okay, so we prepare, okay, I have prepared some solutions for the clone partial Pspm that I picked from the Pspm questions. I already give you the question earlier. Okay, I hope that, okay, some of you, okay, or all of you already go through the questions. Okay, so come, we go together with the first question, and please bring along your statistical tables so we can do it together. Okay, so for the questions one, okay, normally in the question they will state, biasanya dia akan state. Okay, you may highlight macam cikgu buat. Okay, dalam exam you take out your highlight pen, you just highlight. Okay, the important keywords. Okay, for example, for this question, it says that the number of patients. Okay, in your mind, you should know, this is a discrete distribution because we can count the number of patients here. And it says that this is the Poisson distribution. Okay, very good. Okay, very kind. The question they already informed. This is the Poisson distribution. This is the question section 199 and 2000. And with a mean of 7.5 patients in an hour. Okay. Class, you must take note that whenever you have the Poisson questions, you have to be careful on the time interval. Highlight. Okay, this one it talk about 1 hour. So you must take note. The mean is for 1 hour. Okay, A, find the probability exactly 9 patients in 1 hour. Okay, you already know. Okay, this is the same period of time. It's 1 hour. 5 to 14. 5 to 14 patients in 1 hour also, and more than, lebih, okay, more than, okay, 3 patients will visit the private clinic during a 20 minutes interval. Okay, you see or not? They change the time frame. So be careful, take note of this. Okay, and part B, it says that if V is the number of patients visiting the private clinic between 2 p.m. and 6 p.m. Okay, they change also the time from 2 to 6 p.m. Okay, how many hour intervals they have? Okay, and you determine the probability of this. Okay, so this is how, so we tackle the questions. Use the highlight pen to highlight, okay, the important keywords there. Okay, we go through the questions number 1 together. Okay, I think maybe some of you already tried the questions here. Okay, we said that just now, F is the number of patients visit the private clinic in 1 hour. Okay, in 1 hour. Okay, so that's why you must write, okay, the distribution as the standard is the notation that this is the Poisson distribution with a mean of 7.5. Yang ini adalah khas untuk 1 hour. The mean for 1 hour. Okay, the question 1, exactly 9 patients. So exactly. So just now we said that kalau exactly, we convert into the equal sign, sama. Okay, equal sign 9. Okay, so for these cases, you may either read from the Poisson table or you may use the Poisson distribution probability formulas also can. I will show you both answers. Okay, so if you read from the Poisson table, kalau you nak baca. Okay, so you nak gigi number 9. Okay, this one we no need the normal bell because we didn't choose or we didn't change the distribution. So we just use the normal gigi. Okay, it says that. So remember your table, I just now I said that is the cumulative of X is greater or equal. So this means you must read from greater or equal than 9, subtract with greater or equal than 10. This is 10, this is 9. Okay. Can you must please kindly write correctly what you may read. Okay, you just go to the page 14. Okay, page 14 with the lambda of 7.5. Okay, so you read. Okay, you read from the table. Okay, so for greater or equal than 9, we have the value of 0.3380. And for the greater or equal than 10, you have the 0.2263. And you will have the answers of this. Okay, this one is the method if you read from the Poisson probability table. Okay, very good. Rizwan, the answer 0.1144. Very good. Okay. Okay, or you may choose to answer by using the Poisson probability formula also can, if you want to calculate. So you are basically get the same answers. Okay, Tanya, Rizwan, bagus dapat jawapan sebelum cikgu paparkan. Okay, very good. Okay, so we proceed to the questions A2. Okay, A2 also the same. So we talk about 1 hour also, 5 to 14. Okay, 5 to 14 from. Okay, maksudnya dari 5 ke 14. Okay, definitely this one is included. Yang ini ke sini, you punya conversion mesti betul. Must correct first. Okay, must correct first. Okay, so this one normally we won't calculate because a lot. If you want to calculate, you take time. So you read from the table. Okay, so you see how I do class. So 4 to 14, maksudnya semua ni. So I may read from mana? From 5. Saya nak include 14 Saya tak boleh throw away 14. Saya kena greater equal than 5. Saya kena subtract with sini. Greater or equal than 15. Okay, greater or equal than 15. Saya kena guna gigi besar equal to 5. Subtract with besar equal to 15. So I just have this. I just want this only. Okay, ini saya letak dot sebab saya malas nak lukis banyak gigi nak buat. Okay, don't need lah. So I just skip some. I just skip. Okay, I just take note of this value and this value. So definitely I have to read from greater or equal than 5. Subtract with greater or equal than 15. So you bacalah dari table. What is this value and what is this value? Make sure that you read the table lambda 7.5. Okay, you will have the 0.8679 subtract with the 0.0103. So you will get this answer. You will see that class. This row play an important rules. Dia sangat penting. Kalau this formula salah, whole thing salah. So we'll give you 0 for this whole part. So please make sure that this one correct first. How you make sure this correct? I suggest you to apply this betul. Okay, very easy. You just rotate, shaded, then you will read. Okay, easy Okay, very easy. Okay, so we go to the questions number A3. Okay, Dodina. Okay, bagus. Dia dapat jawapan Tanya, Dodina. Okay, so we go to the A3. More than. Okay, class, you notice or not? This question, they change the time interval. So, maksudnya lambda kita need to change. Okay, so we need to change to lambda from 20 minutes. Okay, 60 minutes, we have the 7.5. So, the 20 minutes, we only have 2.5. So, that means we have a distribution with the Poisson with the mean 2.5. This is for 20 minutes. Okay, this is for 20 minutes. Okay, so more than besar. Okay, kalau besar 3. Okay, so I have to read kalau besar 3. Besar 3 tak termasuk 3. So saya ada gigi sini dan seterusnya. So maksudnya adalah besar sama 4. Okay, it's the same with the X is great. You punya table ada equal sign. You have to remember it. Okay, ada equal sign. So this one is equivalent to the Y greater or equal than 4. Okay, okay. So this one you have to change to the page 12 for the lambda of 2.5. So if you read, okay, you take your time to read. Okay, on the page 12. So what you will get for this? So I give you time to read. So you have what? 0.2424. Okay, very good. Okay, somebody already get the answers. You have the 2424. Okay, for these chapters, so you have to make sure that you read correctly on the correct page. Okay, how to read for the correct page? We base on the lambda given here. Okay, we base on the lambda given here. Okay, clear? Okay, so for the next questions B, number of patients visit from 2 p.m. to 6 p.m. Okay, how many hours you have? From 2 p.m. to 6 p.m. Berapa hours frame ada? Boleh somebody answer? Interval frame dia berapa? From 2 to 6. Berapa hours kat sini? So dia punya interval time adalah 4 hours. So sekali lagi we need to change the mean. Remember to change the mean. Don't simply read. Okay, don't simply read. So that means the mean lambda now is become 30. So we have the V as the number of patient visit, okay, for the 4 hours. Ini adalah time frame for 4 hours. Okay. Okay, so now, okay, so to read this, okay, so we have to form the formula first. You look at your petua gigi. I'm going to include 29. I highlight. Less than 32. Maksudnya dia tak termasuk 32 and 31 only. You just shade it. Tengah-tengah saya dah buat saya buat dot. Sebab ada lagi banyak gigi saya tak mampu nak lukis. Okay. Ada 30, okay, 30 je lah actually. Okay, so how we read? So I have to use this. Okay, greater or equal 29. I subtract. Tolak dengan apa? Tolak with 32. Because I want to cut this kan. Tak mau. Greater equal than 32. I just want this. I just want this only. Okay, I just want this only. So I will have my greater or equal than 29 minus with V greater or equal than 32. You make sure that this one is correct first. Okay, only you read. Okay, only you read. Okay, so you will have the 0.5969 subtract with the 0.3814. So we have the 0.2155. Okay. Ridwan Shah dah dapat. Very good. Okay. Thank you. Okay. So, very good. So, we have tried. Okay. Yang ini. Okay. So, nampak ke? Clear? Okay. You may use this method, okay, to help you to form this formula for discrete only. For discrete. Okay. So, we go to the second questions now. Okay. So, we have the second questions on this. Questions number 2 here. Okay, in every delivery of cupcake to a particular restaurant, 30%. Okay, 30% will be returned due to the not favored by the cupcake lover. Okay, so we read. Okay, ini adalah 30% akan return. Okay, suppose that 20. Okay, 20 of the cupcake. So saya boleh anggap this is my sample lah. Okay, my number of trial and okay, and will be selected for a delivery. What is the probability at most? Lebih-lebihnya. Okay, and most fine will be written. Okay, then proceed to the questions B. So, suppose the restaurant will be holding an event requiring 200 cupcake. Oh, 200. Okay, this one already greater than 50. So in your mind, you should know that, okay, I have to do the approximation. That's why this question is based on the binomial and the distributions approximation. Okay, this one kena buat correction of continuity for this part. So remember, okay, this is the year 2017 and 2018 questions. Okay, so questions 1, we have to approximate the probability that between 56 and 62, dia tak ada include. Maksudnya dia tak ada termasuk in between saja. Okay, if the probability of observing less than n cake or cupcake among those delivered are returned is 0.02, use the normal approximation to determine the value of n. Okay, so this is the two main, two common questions, okay, in the exam. Okay, we go through one by one. Okay, so we may use this as our probability of return. That is the 0.3 here. Okay, so basically the questions before we start, we have to, is define first. Define first what is the random variables that you use. Okay, so this is the number of n. F is the number of return cupcake. And S is the binomial. Okay, I'm going to use the binomial to answer this question. So I write as binomial 20. This is the N and this is the probability of success. Okay, since this is still the discrete. Okay, saya still adalah discrete. So saya boleh use the petua gigi. So at most, selebih-lebihnya. Okay, at most is less or equal than 5. Okay, unfortunately, saya punya table tak ada less equal. Saya ada besar sahaja. So, how I do? Okay, class, you see, you have the less or equal. So, you are going to shaded all this. Okay, so saya tak nak ini. So, macam mana? Saya tak nak. So, saya boleh guna keseluruhan. So, I subtract with this kan. Okay, so I use 1 minus. Okay, 1 minus f greater or equal than 6. Okay, 1 minus less than equal than 6. Because this one I can read from the table. Saya kena baca besar equal. Okay. So, baca besar equal. So, I have the 1 minus 1 minus 0.5836. Okay. No, Syafika cakap, okay, 1 minus. Okay, bagus. Okay, 1 minus. So, you will get 0.4164. So, you see, once your this correct, you want to read is no problem. Once this is wrong, whole thing is gone. 3 marks is gone. Okay, so please be careful. Okay, ready? So, take notes of this. Okay, we go through the second B. B is the number of return kit. Okay, now they increase the sample to 200. Okay, this one I says that the n is greater than 50. We have to do the approximation. So to do the approximations to normal, I need the parameter of mean and the variance. So saya kena cari. Okay, NP 200 times the 0.3. So I have the mean of 60. And the variance NPQ, so it's 200 times the 0.3, 0.7. So I have the 42 as my variance. This is why I approximate to the normal distribution. Okay, listen here. During the exam, this step gonna write it out. So how you change from here to here? Okay, normally we will give you the mark. So based on the value and this correctly on 1 mark. Correctly. Okay, so the probability between 56 and 62 will be retained. Okay, this one I says that you must remember you must do the corrections of continuity kan, sebab you ada buat approximation. So you kena add on satu langkah, that is means by corrections of continuity. First of all, we convert this into the mathematical term first. Okay, macam mana kita buat correction? Okay, langkah pertama we draw gigi. Step 2 we shaded the region kan. Okay, besar 656 maksudnya I'm not included. So saya akan shaded this region. I shaded. Okay, besar 56 less than 62. Okay, step 2 I draw my normal bell. I draw. Okay, then I cut. Uh-oh. Okay, I cut it here. So this one I will have the 56.5 and this one will be 61.5. I do the corrections of continuity at 56.5 to 61.5. Langkah ini mesti buat. Must do this first. Corrections of continuity. Okay, you do this first. Since we change to the normal, say we have to do the correction continuity, then only we do the standardized. Baru kita standardize. Okay, standardized biasa kita akan minus the mean, divide by the standard deviation. This one take note bukan divide by the variance. Ini adalah variance sigma square. That's why you have to divide by the standard deviation. Okay, so then you do the calculations. Okay, so you akan dapat ini. Then only you come up with your normal bell here. Okay, so this is 0. And this is the negative 0.54 here. And this is a 0.23. So, shaded. Okay, saya nak kawasan ini saja. So, that means that I have to use 1 minus z greater than 0.23 greater than 0.54. So, we read from the standard table on the page 21. On the page 21, so you read, here you are going to get 0.2964. Okay, this is basically how we answer the questions on approximations. Okay, please make sure that all remembers. Okay, to change, is to do the corrections continuity first, then only you standardize. Okay, so we proceed to the next questions. B here. Okay, it says that the question is less than. Okay, you convert first. It's less than n is 0.992. Okay, since this involve is the CC correction. So before you standardize, so you have to subtract. Okay, subtract. Because you have the n less than n. See, so if you have n minus 1, n plus 1 less than n is here kan. So bila kita buat correction, so dia kena n minus 0.5. And this is the n minus 0.5. And only you standardize. Baru you standardize. Okay, this is CC. And this is standardized. Okay, this is standardized. Then only you do the calculations. Okay, only you do the calculation less than n minus 60.5. Okay, so if you base on this, z is already standardized. So we see where is the locations of z first. Okay, it says that less than n minus 60.5 is 0.992. So maksudnya you punya n minus 60.5 divided by 42 adalah this location. Dia adalah positif. So maksudnya this region. So is 0.992. Okay, 0.992. Okay, saya tak boleh baca you punya z greater than ni, tak boleh nak baca. Okay, so I have to do the adjustment. 1 minus. So, saya kena guna 1 minus. Okay, 1 minus PZ greater than n minus 60.5 divided by first 42 equal to 0.992. I rearrange. Okay, only I get the Z 0.008 here. So, baru saya baca ini. Okay, so to do this class, I suggested that during the exam, if you nak baca terbalik from reverse here, you may go to the page 24. Okay, you go to the page 24 first. Okay, you go to the page 24, so you will notice that. Okay, so you will read that 0.008 ini dia punya value adalah 2.4089. Okay, then you rearrange, only you will get the n equal to 76. Okay, kalau you baca dari page 21, you only can get 2.41 only. Okay. Okay, boleh. Okay, boleh. Okay, so okay, so this one you may go back and try. You see, you open your page 21. Okay, then you can see. Okay, so we proceed to the third questions here. The length of the newborn baby at a hospital. Okay, so when we read in the exam, this is a 2015 question, the length. Okay, in my mind, I should know, okay, this is the continuous. So this should be a normal distribution. Dan dia pun beritahu pun, this is the normal. Okay, with the mean of 52 and the standard deviations of 2.5. Okay, a baby length is considered normal if it is between 46 and 56 centimeters. Okay, it says that the length of baby adalah normal if the length is this. From a list of 100 birth records selected randomly for the particular year at hospitals. Okay, how many baby? Okay, berapa baby ni? Jadi bilangan baby expected to have the normal length. Okay, so if I read the question, so dia ada dua benda that we want to find. Satu, kita cari probability of normal length. Okay, second baru kita cari number of baby. Okay, so kalau nak cari ini, so kita kena cari probability. Normal length ini adalah in between 46 and 56. Okay, so macam mana we do this? Okay, so I denote that. Okay, the S is the length of the newborn baby here. And I will do, this one I will do by using the normal distributions with the parameter mean of 52 and the variance. Ini hati-hati dek, because they give you standard deviation is 2.5. So if you want to do the notation of the normal distribution, you must write at 2.5 power of 2. Okay? Okay, so after this, we say that okay, the normal length is between 4/6 and 5/6. Okay, then we just do standardize saja. Sebab ini asalnya adalah normal distribution. We just need to do the normal standardize. Okay, then we calculate. Okay, I will get this. Negative 2.4. And this is 1.6. Okay, so I want to do the region of this. So I may use 1 minus greater than 1.6 and greater than that of 2.4. Okay, and this one I may read from the tables, page 21. Okay, I will get the probability of 0.937. Muhammad Ruzaini. Okay, very good. 0.937. Okay, so ini bukan final answer yang kita nak. Ini just probability aja kan. Kita nak number of baby. So we may multiply this with the 100 sample MP here. Okay, so we will get 93.7 baby. So lebih kurang 94 baby lah. Bilangan baby tak boleh pecahan Okay, tak boleh decimal base. So lebih kurang. Okay, is approximate to 94 baby, dia adalah normal. Okay, this is the questions on 2015 and 2016. So saya harap sampai saat ini you dah boleh lah estimate okay, what kind of questions will come out. The most important thing that first step, you must determine correctly which distributions are. Second step, okay, then you must convert the word the parameter correctly. Then only you read from the table. Okay, so this one be careful. Okay, we proceed to the question number 4. I picked this question from the year 2007. I like this question more because you will see that in one question, they will ask 3 distribution. Nampak? Dia akan tanya tiga sekali. Binomial, Poisson, and distribution approximations. Okay, how we answer this? Okay, sekarang ini sangat interesting Ini pada 2007. Okay, so this is that the number of letter. Okay, the number of letter. So, okay, ini adalah discrete. Received by Jeffrey have a Poisson. Okay, with a mean of 4. Okay, bagus. Dia dah cakap dengan jelas. This is a Poisson. Okay, so first question, it says that find the probability that Jeffrey will receive between, sekali lagi, between 3 and 11 letter in a day. Okay, in a day. Okay, if the probability that Jeffrey will receive not more than n letter in a day is 0.7851, determine the value of n. Okay, not more than n adalah 0.7851. Okay, cari bilangan letter. Okay, if 14 day are chosen at random, B dia tukar. Okay, first part ini still Poisson. Okay, second part. Okay, so dia tukar, they become a binomial. You see, if 14 day are chosen at random. So this one I'm going to do. Okay, between 3 and 11 letter of period of. Okay, so kita dah cari probability ini dekat bahagian part A1 ini. Okay, we use this as the probability of P dia. So this is the N and this is the P, and we are going to get the 10 day yang receive letter between 3 and 11. Okay, and thirdly, so if 120 day are chosen. Okay, ini N dia besar 50. So kita perlu buat approximation. Okay, ada approximation. Okay, so how we answer this? This question is very interesting. Okay, how they change the flow from Poisson to binomial and to approximation. Okay, we look at the A1 here. X is the number of letters received by Jeffrey in a day. Okay, just now in the question state clearly X is the Poisson with mean of 4. Okay. Okay, so Jeffrey will receive between 3 and 11 letter in a day. Between, dia tak ada sama dengan. So, in between 3 in a day. Okay, so we come out our gigi again. Between. Okay, besar 3. So, besar 3 tak termasuk 3. Okay, until less than 11. So, less than 11 adalah sampai 10 lah. Okay. Okay. So, macam mana kita nak read? Okay, how to read? So, I am to read greater or equal than 4, subtract with greater or equal than 11. Okay, greater or equal than 11. So, I will read from the table. Okay, ini mesti betul dulu. Kalau tidak, you don't know where to read, how to read. Okay, so you read from the table. Okay, so you have 0.5665 subtract with 0.0028 here. So we have the 0.5673. Okay, ada orang dah dapat Izazi dengan siapa tu? dah dapat jawapan so bagus. So they know how to do. Okay, hopefully this chapter you can score lah. You have 25 marks here. So you can score at least 24 ke atau you get full mark also can. Okay, kalau dapat full mark then easily. Okay, the rest questions so you can try. Okay, so we go to the question A2 here. Okay, now we change. Okay, it says that Jeffrey will receive not more than, tidak lebih. Sama boleh tapi dia tidak lebih. Not more than letter n letter in a day. Dia nak cari n ini berapa. Okay. Okay, so F is less or equal n 0.78. Okay, so macam mana kita nak buat ini? Okay, so we see that kita ada n minus 1, n plus 1, n minus 2. Tapi kita punya table tak ada less, kita ada besar. So kasarnya dia adalah less than n kan. Okay, ini adalah n plus 2. Okay, so saya nak ini je. Okay, what should I do is that I use one whole thing. Okay, I subtract with the m plus 1, betul? So I subtract, so I will get this region. Okay, so I rearrange, so I will have the, saya dah lukis lupa. Okay, sorry. So nak region ni. So I use one whole thing, so subtract with this, kata one. Okay, so I rearrange. I will get 0.2149. Okay, so you have to go to the Poisson. You pergi ke mean yang lambda dia is 4. Okay, if I no mistaken, so it's in the page 4. Page 4. Sorry, page 4 pula. Sorry, page 12. Okay, so you read, you cari sehingga you jumpa this one. 0.2149. So you will get greater or equal than 6 from the table. It says that greater or equal than 6 is 2149 here. Okay, so therefore m plus 1 equal to 6. So your n is equal to 5. Okay, Izazi dah dapat jawapan dia. Okay, bagus. Okay, Muhammad Adrian. Adrian pun dapat. Okay, so bagus. Okay, so this is basically how we do this lah. Okay, so then we proceed to the question number B. B dia dah tukar kan? Dia dah tukar number of day pula. Tadi kita cakap number of letter. So kita sekarang cakap number of day. When Jeffrey received between 3 and 11 letters here, so we change the variables to the normal distribution. Okay, yang ini kita dapat dari mana, dek? Kita dapat dari part A. Okay, dia dapat daripada part A that you use the Poisson to calculate. Okay, kita dapat dari part A. Okay, will receive between in the period of 10 days. So 10 hari, they will receive between 3 and 11 letter. So PY equal to 10. Okay, ini kelas boleh tak kita baca ni from the table? Boleh ke? Kalau you rasa boleh, you tekan 1. Kalau you rasa tak boleh, you tekan 2. Okay, you rasa boleh tak baca? Okay, boleh? Give response please. Ada? Boleh baca ke? Can we read this from table? Boleh ke? 2, tak boleh. Okay, tak boleh. Memang tak boleh sebab this is out of the range. Bagus. Kalau tak boleh, so kita kena guna formula untuk calculate. Okay, very good. Tak boleh. Memang tak boleh pun. So kita kena calculate. Okay, this value is the 1 minus 0.5637. Okay, 0.15637. Okay, you kena calculate. So make sure your calculator have battery. So nak calculate ini not easy. Okay, so this is the binomial coefficients. So you read, so you will get 0.1175. Okay, so since this is out of the range or the limitations of the table value of P, so you can use the formula to calculate. Okay, okay, good. Okay, we proceed to the C here. C, number of days received between 3 and 11 letter also. Now we increase the sample to 120. Just now I said that we have to do the approximations. Okay, and P 120 times the 0.5637. So we get the mean of 76. Sorry. 67.644. So the variance of 29.51 here. So kita akan ambil ini sebagai parameter for the normal. So we will have the normal distribution. So we approximate to the normal. Once we approximate, so do remember to do the continuity correction step. Okay, so it says that is berapa? The question it says that not more than, I think, Less than. Okay, dia adalah less than. Probability less than 80 days. Less than, so U anda adalah less than. Sorry, ini tukar ke U. Sebab saya guna parameter U. Okay, so before this to this, so I have to do the corrections of continuity first. Okay, so less than 80, so maksudnya dia less than. Okay, draw the normal line. Okay, you cut point here. So this one will become 79.5. So you do the corrections of 79.5. U is less than 79.5 because I use the parameter U. Okay, you do this corrections of continuity step first. Only you do the standardized. Okay, so you akan dapat yang ini. Okay, so bila kita dapat normal, so we try to draw our normal distribution. So we have the 2.18 here. Okay, so untuk nak evaluate this value, so I may use 1 minus z is greater than 2.18. So we reach from the table 1 minus 0.0146. So you have the 0.9854. Okay, so basically, so you will notice that we will have, if you have the questions of approximations, first step. Okay, first step yang ini. Okay, ada soalan tanya, why should we do discrete before we do CC? Yeah, because basically this question is the binomial distribution. Dia punya original adalah binomial distribution. Since the sample is too large, okay, it is suitable for us to use the normal to calculate. Sebab you punya MP dah besar 5, so you guna normal pun you boleh kira. Kalau you insist nak guna binomial and we cannot read from the table, you have to do a long calculation. Okay, why we should do? Yes. Because we nak tahu, kita nak betulkan this is the original, dia adalah binomial. Okay, then we change to the normal. Okay, boleh? So that's why kita kena buat correction first. Sebab kalau binomial dia adalah macam gigi, so kita kena buat dia macam, yang ni saya nak tukar dia bell shape. Okay, saya kena buat anjakan lah. Less than 90. So kalau less than 90, 79 adalah sini. Tapi sebab dia punya gigi, saya kena ambil region start from here. That's why saya kena buat corrections of continuity first. Okay, because I change from the discrete to the normal. So this is the step that you have to take note. So I hope that you take note of this. Okay, boleh? Okay, question number 5 adalah latest 2019 punya question. Okay, so it knows that the mean numbers of accidents occurred in the road is 1 in a month. Okay, 1 in a month. Okay, so kita define the random variables and identify its distributions. Okay, find the probabilities that there is no accident in the next 1 month. Okay, ini 5 months and accident free less than 2 accident free. Okay, so yang ini, so this question number 5 ini adalah 2019-20 punya question. So if you read the question, we basically know that at beginning the question is a Poisson distribution. Dia berlaku satu dalam tempoh 1 month. So kita ada mean 1 dalam interval of 1 month here. Okay, they ask you to define the random variable. Okay, then there is no in 1 month, 4 months. So nampak ke sini dia tukar the interval time from 1 month to 5 months. So take note that your lambda should be changed. And out of the 7 months. Okay, so lepas tu dia do other things that dia buat dia dalam binomial distribution. Okay, they are less than 2. Less than 2 accident free. Accident free maksudnya no accident lah. Okay, ini kita boleh ambil P dia from the B1 Okay, from the B1. Okay, so basically they give you 2 marks if I'm not mistaken at that time. So we have to define, they ask you to define the random variables and identify its distributions. Okay, F is the random variable, so we talk about number of accidents occur in 1 month. Okay, jawab dengan penuhnya number of apa in interval time dia. Baru dapat B1 1 mark. And the distribution that I want to use is the Poisson distribution with the ini adalah you punya lambda lah, lambda of 1. Okay, so ini adalah maka untuk 1. Okay, then we proceed with the B. Okay, so first thing it says that there is no accident. Tak ada accident in the next 1 month. Okay, period dia still sama. The time interval there is still 1 month and 1 month. There is no changing of lambda. So lambda is still 1. Okay, so there is no. Maksudnya kosong. So kalau kosong, you nak baca. So I just want kosong kan. So you boleh guna besar sama kosong. Subtract with the greater or equal than 1. Okay, kalau you want to read, kalau nak read. Okay, so you can read from the page 12. So 1 minus 0.63 to 1 and get 0.3679. Okay, kalau tidak, okay, you may use the formula to calculate. Okay, you boleh calculate melalui formula. Dekat dia ada equal sign. So you may use the formula to calculate. So basically, you will have the same answer. Okay, so this one I think should be no problem for you. Okay, untuk B, okay, you will notice that they change. Okay, dia tukar So baca Poisson punya soalan ni kena baca sampai habis. Okay, so it says that in 5 months. Okay, in 5 months. So kalau in 5 months ini, so kita kena tukar lambda dia. 1 month 1. So 5 month, so dia adalah lambda dia adalah 5. Okay, not more than 4. Not more than 4. Tidak lebih daripada 4. Okay, so tidak lebih daripada 4. Okay, all this region, kan? Okay, so saya kena guna apa? Saya kena guna satu keseluruhan. Okay, I subtract with the greater or equal than 5. 1 tolak. Sebab you punya table ada besar equal. Okay, so besar equal 5. Okay, so you read from the table this value. So baca table this value in the page of 13 here. Okay, so you will get 0.4405. Okay, 0.4405. Okay, so you will notice that class. So this step is very important, these two. Kalau ini salah, ini akan salah. So kalau ini betul, bawah mesti betul dulu, only you will get the correct answer. So these two steps make an important rules. Okay, to guide you to get the correct answers. Okay, boleh? To guide you to get the correct answers here. Okay. Okay, so far, okay? Okay, so you go to the question B. Okay, sekali lagi, accident free. Okay, now they take the sample of 7 months ini. 7 is the end and this is the probability of success. Ini kita ambil dekat part atas B1. Okay, so less than 2 accident free month. Less than 2, kurang daripada 2. So kurang daripada 2 adalah 01. Betul? 01, less than 2. So ini 2, 01. So discrete mesti mula dengan 0, 1, 2. 3 sehingga seterusnya. So you take this one and this one. Since ini adalah out of the limitations in the table. So kita tak boleh baca this from the table. So we have to do the calculation. So kita kena kira. Okay, since by using the binomial probability functions formulas. Okay, then you will get the answers of this. Okay, then only you will get the answers of 0.2046. Okay, boleh? So you will notice that you kena baca dia punya keyword And you kena relate, okay, what is happened in the previous part. Okay, so dia mesti ada relationship. Okay, kalau soalan yang sama Okay, boleh? Okay, so kita ada lagi 2 question. Okay. Sekarang 10:20 Okay, we still have 1 hour, boleh? Okay, so we have the question number 6. So you read through the questions first. The number of text messages received by Rosnida during a fixed time interval is a mean of 6 messages per hour. 6 message. So maksudnya ini adalah you punya lambda. Ini adalah you punya time frame 1 hours. Okay, so first question is that I'm going to find the main is exactly 8 message between 16 to 20 on a particular day. Okay, so bila kita baca ini, okay, exactly, so equal 8 kan, kita tahu. Okay, on a particular day, tapi dia punya time masa ini kita talk about masa time, 1 hour. Ini kita akan dapati actually 16 to 18 berapa hours, dia adalah 2 hours. Okay, dia adalah 2 hours. Okay, dia adalah 2 hours. Okay, so kita ada changing of lambda. Okay, then B is knows that has received at least 10 messages between ini on a particular day. Find the probability that he received 13 message during that time. Okay, dia macam ada. Okay, so this one you have to take note that okay, at least 10 message. It is knows that. Okay, is knows that. Okay, bila kita baca ayat ini, dia nak cari probability he receive 13 message in a time. Okay, is knows that. Okay, ini adalah conditional event. Okay, ada probability. So soalan ini agak complicated tahun itu ramai orang salah ini sebab dia tak berapa faham this question. Okay, actually this question adalah conditional probability Okay, is knows that. So ini adalah dia punya condition, ini apa yang dia nak cari. Dia adalah something A given B. Okay, okay, we do one by one first Okay, so if we look at the first question, okay, so basically original dia punya is given number of text messages ni lambda ni adalah 6. Ini for 1 hour. This is for 1 hour. So bila kita baca kat sini tadi saya cakap dia adalah 2 hours. That's why dia punya lambda change to 12. 2 times 6. So you will get a 12 here. So we have the new the Poisson distribution is the interval time of 12. Because ini adalah for 2 hours. Okay, dia adalah for 2 hours. So exactly 8, sorry. So if you calculate, so you will get 0.60655. Okay, correct. Muhammad Ruzani tanya, so correct dia punya answers. Atau if you want to read, kalau nak baca, ada orang je suka baca. So you will get roughly the same answer. Okay, bagus tanya Muhammad Ruzani, bagusnya dia jawab dengan betul sebelum saya papa jawapan. Okay, very good. Okay. So this is how we read Okay, how we do the answers. Okay, so I harap you dah boleh tahulah bila nak baca, bila nak kira. Okay, bila kita ada equal sign, okay, kita boleh kira kalau tak banyak, kalau a lot, so it's better you read from the table. Okay, so yang soalan ini, yang ramai orang salah hari itu. Okay, is knows that. So ini adalah probability of conditional. Okay, so have received at least 10. At least 10. So sekurang-kurangnya besar 10 between this time period and find the probability. Find the probability ini dekat depan. Dia receive 13 text message. 13 text message. Okay, so since dia punya time interval still 2 hours, so kita still akan guna lambda yang 12 lambda yang 12. Okay, find the probability that x equal to 13 given that x is greater or equal 10. Okay, so kalau still remember, kalau you masih ingat lagi, so kalau condition in chapter 8 I think, okay, so ini ada A tindan B divided by the PB, betul? So this is the A and this is the B. So, betul ke? Okay, kalau kita nak tindan dua event ini, so you ada 10, 11, 12, 13 and so on. So greater. And you tindan. So kita ambil kawasan ini je lah. Kalau kena greater than 10 tindan with the intersect with the x equal to 13. So we only have the probability of x equal to 13. Okay. Divided by the condition is x is greater or equal than 10. Okay. Yang ini. Okay. Dan kita akan dapat ini. Okay. And you will get this. Okay, so to get the x equal to 13, so if you want to read, kalau you nak baca atau you nak kira, you read from the table. You get 0.1055. Okay, yang ini, if you read from your Poisson table, you get 0.6576. So this is why you get the 0.139 here. Okay, 0.139 here. So ini kita buat separately lah. Ini kita read direct. Okay, yang ini kita ambil dari sini. Okay, so tahun 2017 so they come out on these questions yang ada conditional probability. Okay, boleh? Ini yang quite tough lah hari tu so dia keluar yang ini sekali. Okay, kita ada lagi last questions, I think one more before we end the sections here. So we will have question number 7 yang saya ambil question 2018. Okay, so if you look at this, the amount of semin ini mean of 39.3, ini adalah mu, ini adalah you punya standard deviations. Okay, so bag of semen is randomly selected. Okay, find the probability that the bag weight is more than 40 kg. Ini tak ada apa, biasa je. If the probability of the bag weight not more than m kg is 0.95, determine the value of m. Okay, so not more than. Okay, tidak lebih. So tidak lebih, biasa dia akan less or equal than m kg. Tapi kalau untuk normal, though ini tak ada kesan lah, equal sign tak ada kesan. Okay, and see a total of 5 bag. Okay, a total of 5 bag. Okay, you akan nampak. They seems like change the distribution. Okay, the above part, dia adalah normal. Okay, so the part B ini, atau sorry, part C ini, this is change to the binomial. Okay, the apply. Okay, the switch the situations to the binomial. Okay, a 5 bag is chosen. Find at least 4 bag with more than kg, 40 kg. So you will notice that kalau kita guna binomial, kita perlu n dengan p. So p ini, okay, so basically kita boleh get from the part A lah. Okay, so you nampak so dalam exam you kena pandai pusing. So how we find the n? So you have to know each for the each distribution. So what is the main parameters that they need? Okay, for you to calculate the probability. So you kena cari dia punya parameter. Okay, so we look at the questions number A here. Okay, the semen's bag weight. Okay, ini adalah you punya lambda variable. So you want to calculate the weights here. So mean ini adalah 39.3 and the variance is 0.9 square. Okay, make sure that sebab ini adalah sigma square kan, dia punya parameter adalah variance. Okay, the weight is more than, lebih besar. Okay, kalau lebih besar, we convert to the mathematical term is lebih besar 40. Okay, so if we do the standardized process, 40 minus 39.30 divided by 0.9. So we calculate 0.7. So ini, so if you look at your bell here, 0.78. Yang ini, so kat positif lagi. So we can read directly from the page 21. So you will get 0.2177. Yes, correct. Muhammad Ruzani. Okay, you again correct. Okay. Izazi 0.2177. Okay, you will notice that kalau originalnya soalan dia adalah normal, so we no need to do any corrections. We just do the standardized process. Standardized process. Okay, boleh? Okay, good. Okay, so we proceed to the questions number 2 here. If the probability of the back weight not more than kalau kita ikut table dia adalah kurang sama M. Okay, kurang sama M. Sebab dia adalah normal, so dia ada conjugate yang ini dia tak main peranan lah. Okay. Okay, so kita buat standardize dulu sebab kita standardize 39.3. Okay, so kita akan baca the other way round yang besar. Okay. Ini nak letak sama pun tak apa, dia tak ada kesan Okay. Okay, so kita akan calculate one, because if we look at this. Okay. So 1 minus X besar. So you have the 0.05 here. So we read this one. Okay, so kalau kita nak baca ini dalam exam, we kindly go to the standard table on the page 24 first. Okay, you go to the page 24 first. Okay, so you will notice that the value is 1.6449. Okay, 1.64 based on the page 24 and you rearrange, so you akan dapat lebih kurang 40.8 lah M dia, disim dia. M is the weight, weight dia boleh decimal plus tak apa. Okay, so you will get this. Okay, boleh? Okay, so for these cases, sebab dia original dia adalah normal distribution. So we no need to do the corrections continuity Okay, yang ini kita buat standardize sahaja. Okay, boleh? Okay, so soalan yang last sekali adalah ini. The total of 5 bags of cements are chosen at random. Find the probability that at least 4 bags. Okay, bila kita baca soalan ini, so you will notice that this one is seems like switch to the binomial distributions. To apply this, so this is the number of bag pula. Okay, the distribution is the binomial with the n5 and 0.2177. Okay, this one you get from the above part. Okay, so since we say that at least 4. At least 4. Okay, and kita ada 5 je. So, dia adalah 4 and 5 lah. Okay, since ini is out of the limitation, so kita tak boleh nak cari. So, kita hanya boleh kira You must calculate by using the, okay, because it says that at least greater than 4. You punya simin adalah 5 je, 0 hingga 5. So, we calculate this one and this one. Okay. Okay, so we do the calculations. So you will get the 0.00927. Okay, boleh? Boleh? So this is the final question. I think ada somebody asking the question. So boleh minta moderator postkan question So Jing Yun eh? Like we should do the petua gigi. Okay. This is what? Could you explain the flow of step to answer the question? Like we should do the petua gigi before we do 1 minus f equal k and determine apa tu, it is positive or negative or standardized. Okay, so students, so we are going to do we use the petua gigi palsu to help us to form the formula actually. Okay, like we do. Okay, for example, okay, this one. Okay, ini adalah correction. Bukan saya nak yang petua yang biasa je kan. Mana dia? Okay. Okay. I think you means like this, right? Okay. The petua gigi palsu, we have two kind. Okay, one is we use for the discrete variables and the other one is we use the corrections of continuity. Okay, so for the correction of continuity parts only we need to do the normal bell. Okay, so for example, yang soalan ini 5 to 14 patient ini. Okay, 5 to 14 patient. Okay, how I'm going to use the petua gigi palsu because I want to write the formula of this because I want to read from the table. Okay, so basically, so I will draw like this. So first step, I draw my gigi first. Okay, 5 to 14. Okay, 5 to 14, that means I'm going to include 5, 6, 7, and so on until 14. Okay, this is the regions that I want. Okay. Okay, what to minus is that, okay, so this is why when I get this, so I know that, okay, my table is the value that x is greater or equal. So I have to read from the greater or equal 5, this one. Subtract with greater or equal 15. So baru saya buang dia. This one. You mean like this, right? You mean this, right? Okay, so I make sure that this petua will help you to form this formula. Okay, then only you read what minus what. Okay, so for the questions, katakan yang macam ni punya greater than katakan 14. Okay, kalau ya ada soalan yang macam ni, okay, I use my petua, so greater and equal than 14, so I start from 14, 16, and so on. Okay, I will get this. So I can read directly. Okay, I can read directly. So kalau you ada question yang less than 14, okay, katakan you ada question less than 14. Less than 14. Less than 14. So kalau less than 14 adalah katakan ini 13 14 13, so ini this region less than 14 dia tak termasuk 14. So saya nak buang, so saya kena guna semua keseluruhan subtract with the 14 and above. Probability s greater or equal than 14. Then only you read. So ini ada satu adalah whole lah, whole thing subtract with the value of this. Okay, this is without doing correction of continuity because this is still discrete. They're still in Poisson. Say for the case that we change from binomial to normal only, okay, we are going to extra one step. Macam soalan ini. Okay, macam soalan yang ada buat correction yang mana? Yang ada approximation. Mana dah? Yes, this. Macam soalan ini, we change, right? We change the distribution from binomial to normal. This type of question we need to do extra one step lah. So before we do anything, say ini ke sini kita buat correction. Okay, correction ini kita kena buat less than 80. So dia adalah kawasan sini, less than 80. Okay, so kita buat normal bell. Okay, kita cut ke sini. Okay, that's why kita akan correction ke 79.5. Ini kena extra one step. Ini sebab kita kena buat normal bell. Okay, we use the petul gigi also, but we add on satu normal sebab we change to normal. Okay, then only you do standardize. Sampai sini kita dah tak payah guna petul lagi because it change already in the normal bell shape. Okay, okay, clear? Boleh? So, boleh then only we do the normal process lah. Say standardize, we read from the normal table and we get the answer. Okay, actually this step and this step is quite important lah. Kalau binomial to normal, kita correction. Okay, kalau the rest, yang macam Poisson dengan binomial saja, kita buat gigi je. So what to what? That one is the formula that normally student will make mistake. Okay, dia boleh first saja dia betul, then the second they read or they get wrong. So if you form wrongly the question. Okay, boleh? Ada soalan lain macam tak ada? Okay, so I think so this is all for my sharing today. Okay, so minta jasa baik anda isi student feedback for our slot 4 ini. Okay, if you think that this slot help you a lot, so can you please kindly like our page atau subscribe our channel ini atau give me a like lah at least so for support us to continue. Okay, boleh? So before I end this, ada dua benda yang saya nak encourage or send to you all. So hard work and sincerity always pay off. So your self-belief and confidence. So ini important So tak lama lagi you akan sit for the exam. So you punya self-belief and confidence will help you to assist your success. So you means hopefully all of you jawab exam dengan penuh keyakinan So you yakin you boleh, so you punya jawapan pun betul. Maksudnya, okay, boleh? So you good luck for you for the exam. Okay, so remove all your fear and have faith. Okay, so saya yakin you semua boleh kita dah go through 4 slot, 4 main chapters in Pspm for the mathematics. So kalau you boleh score 4 chapter ini, so I think for sure lah A di tangan anda So 4 main chapter yang kita buat untuk daripada Medengkang, the slot 1 Miss Nurul Jaswani, okay, minggu lepas Mr. Chow and minggu ini last sekali saya sendiri. So we already give you the guidance, okay, the chapter review and what is important in this 4 main chapter. So hopefully, so you go through balik nota summary yang kita buat. So you score 4 chapter ini, saya rasa you boleh dapat A lah. So ingatlah, so jawab exam dengan penuh keyakinan. So our smart way to success group. So we wish all of you good luck So for sure, so you will get A. So if you willing to do, Okay, if you willing to do the revision, so willing to study, so saya rasa tak ada masalah lah jawab exam. Okay, okay, that's all for today. Thank you very much.